Hello, hello. It's time for math. Today we are doing lesson 1 in module 1, and it is all about unit rates and proportions. It is titled Unit Rates Involving Ratios of Fractions. Go ahead and do these 5 warm-up questions. Pause your video so that you have some time to work on it, and when you are done with that, come on back and we'll go through the answers. All right, welcome back. Let's look at your answer, or the work here. So I wrote them over here so you can see me doing the work. We're going to start with number 1, 2/3 divided by 1/4. Remember, when we divide a fraction, we have to multiply by the reciprocal. The reciprocal is the fraction that I would multiply by to get 1. I have to switch the numerator and the denominator. So number 1 is going to be rewritten as 2/3 times 4/1. That's my reciprocal for 1/4. Now I have to check to make sure that there are no common factors diagonal from each other. Well, 2 and 1 are already as simple as they can go, and 4 and 3 don't share any factors. So we're going to multiply straight across. 2 times 4 equals 8, and 3 times 1 is 1, or is 3. So we have 8/3 or 2 and 2/3. Either answer is okay. 8/3 is an improper fraction. 2 and 2/3 is a mixed number. Both are correct. Number 2, 7/8 divided by 3/4. I still have two fractions here, so we're going to rewrite and multiply by the reciprocal. So 7/8 times 4/3. I'm going to look for common factors. Well, 8 and 4 both share the factor of 4, so I'm going to divide them by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. 7 and 3 don't share any. Let's multiply. 7 times 1 equals 7. 2 times 3 equals 6. This also equals 1 and 1/6. Problem number 3. We have some mixed numbers and a whole number here, so we've got to do a little bit of math, which we're already doing. So to turn a mixed number into an improper fraction, I multiply my denominator times my whole number. So 5 times 1 is 5, and then I add my numerator. 5 plus 3 is 8/5 divided by, 2 is a whole number. I don't have to do anything. I just need to put my 2 over a 1. Now I need to rewrite to be able to multiply by the reciprocal. So 8/5 times 1/2. I'm going to look for those common factors. Well, 5 and 1 are already simple. 8 and 2 share a common factor of 2, so I'm going to divide both by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. 4 times 1 is 4. 5 times 1 is 5. I don't have to do anything with that. 4/5 is already as small as it can go. All right, now we have two mixed numbers. So same as before, we're going to rewrite with improper fractions. 6 times 3 is 18, plus 5 gives me 23. 6 divided by 3 times 1 is 3, plus 1 is 4/3. Same process. Now I have to multiply by the reciprocal. 23/6 times 3/4. I'm going to look for common factors. 23 and 4 don't share anything. 6 and 3 both share 3, so if I divide by 3, 3 becomes 1. 6 divided by 3 becomes 2. 23 times 1 is 23. 2 times 4 is 8, or 2 and 7/8. Now number 5 was a word problem, so let's look at it. Kenji buys 3 yards of fabric for $7.47. He realizes later that he needs to buy 2 more yards of the same fabric. How much will the extra fabric cost? Well, let's go look. So, if I have 3 yards of fabric at $7.47, how much is 2 more yards going to cost? In order to figure this out, I have to figure out how much 1 yard costs. So I'm going to divide my total cost, which was $7.47, 47 by the number of yards I bought, which was 3. So 7 divided by 3 is 2. 2 times 3 is 6. 7 minus 6 is 1. I bring down my 4. 3 goes into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. I bring down my 7. 3 goes into 27 9 times. 3 times 9, 27. When I subtract, I get 0. I need to add my decimal. So we now know that 1 yard equals $2.49. I have to buy 2 more yards. So what am I going to do? Well, if I have to buy 2, I need to take that $2.49 and either multiply it by 2 or add it together however many yards I need. So I could do $2.49 times 2. 2 times 9 is 18, carry the 1. 4 times 2 is 8, plus 1 is 9. 2 times 2 is 4, so I could $4.98 that way. I could also do $2.49 plus $2.49, 18, carry the 1, 9, put my decimal, 4. I get the same answer. Both ways work. So let's go check our answers. We got them right. So what are we doing today? Why is this showing up? All right. What are we doing today? We are looking to compute unit rates associated with ratios or fractions, including ratios of lengths, areas, and other quantities measured in like or different units. How will you use these? Well, you can make sense of quantities such as a unit in a unit rate. You can use mathematical vocabulary to communicate with others, and you can explain how the structure of a complex fraction allows you to simplify it. All right. What vocabulary will you learn? So, unit rate. What are some of synonyms for the term unit rate, Well, let's go look at what unit rate is first. So a unit rate is a comparison of a first quantity per every 1 unit of a second quantity. This is what we're working with today, is unit rates. So what are some synonyms? A unit is an item, a piece, a group, a part, an element. It's those individual things that are part of that is a unit. So a unit rate would be how many of those pieces I have for one total piece. All right. And I got all kinds of extra things going on here. All right. Unit rates involving fractions. So in Japan, millions of people travel between locations in bullet trains along a series of high-speed rail lines known as the Shinkansen. These trains can carry passengers from the capital city to Tokyo, on the east side of the island, to the ancient city of Kanazawa on the west side, a distance of 282 miles in only 2.5 hours. So, in the US, federal regulations limit the maximum speed of passenger trains to 59 miles per hour. How long would it take for a US passenger train traveling at this rate to cover a distance of 282 miles? So let's do a little bit of math. All right, we'll come back to that. So if I have 282 miles, and I can only go, it says 50, let's go to 60 miles an hour. Let's round it. How long is that going to take me? Well, I could do division. 282, oops, that says 86. 282 divided by 60. I gotta get, let's see, how many times does 6 go into 28? 6 goes into 28, 4 times? So 60 is going to go into 284 times, which gives me 240. If I subtract 2 minus 0 is 2, 8 minus 4 is 4, and 2 minus 2 is 0. How many times? We had to add our decimal, add a 0, bring it down, 420. 6 goes into 42 7 times, so 60 probably goes into 420 7 times. Let's do the math. 7 times 0 is 0, 7 times 6 is 42. If I subtract 0, 4.7, 4.8 hours. This one equals 4.7, but remember we rounded our mileage, or how fast we were going. Take about 4.8 hours. It only takes 2.5 hours to go that far in Japan. How fast do you think that train was going? How could we do this quickly without writing everything out? Well, I know that the train has to go 282 miles. I could guess that, let's say it goes about 100 miles an hour. And we have 2.5 hours. So if I have 2.5 hours, how many sets of 100 would I need to have? I need to have 2 to get to 280. And then I have half an hour would be another 50. That's only 250. So I know that that train is going over 100 miles an hour. That's really fast. But that's all unit rate. It's all the same. So the train's rate can be written as a fraction. This fraction is considered a complex fraction. 282 miles divided by 2.5 hours. Look at that fraction. How does this fraction compare to other fractions you've seen? What do you think it means for a fraction to be complex? So what I notice is different, as there's a fraction in my fraction. So we're going to have to figure out how to solve that. We're not solving this right now. What a complex fraction is a fraction whose numerator or denominator or both are fractions. And that's what we see here, as we see a fraction within our fraction. So using this, we're going to get ready to learn how to do some unit rate stuff with fractions.